In 3.3, we are going to learn some rules for differentiation. And these rules are going to make finding the derivative of a function a lot easier. Okay, and we're going to start with a couple of reminders. The first one, the derivative of a function at a point is the same as the slope of the tangent line to the graph at that point. And the derivative of a function at a point is also the same as the slope of the graph of the function at that point. Okay, and the first rule you're going to learn is the constant rule, which says that the derivative of any constant function is 0. And to help you guys understand that, I'm going to take some random constant, okay, constant function. So f of x equals 5, for example. And that's just random. I could have said f of x equals 1, f of x equals negative 2. The point is that f of x equals a constant value. Okay, when f of x equals a constant value, our graph is a horizontal line. Okay, it's a horizontal line that intersects the y-axis at that given constant value. Okay, and in your previous math class, you learned that the slope of a horizontal line is 0. Okay, and we put the two concepts, the slope and the derivative, into play. Remember that the slope, remember that the derivative is just the slope. So if the slope is 0, then the derivative is 0. Okay, and this applies, okay, whenever, let's say, whenever the function is a constant function. So here we have the slope or the graph of negative 1. So, I'm sorry, f of x equals positive 1, not negative 1. And the slope is still 0. Okay? We could have used negative 2. And so f of x equals negative 2. And the slope is still 0. No matter what, if f of x equals a constant, the slope will be 0. Therefore, the derivative is 0. Okay, the power rule. This power rule is going to be a rule that you guys will begin to use from this point on, almost on a daily basis here in your calculus class. Okay, so the derivative of x to the n is just n times x to the n minus 1. This rule allows you to find the derivative of a function without the limit process, that long limit process that you learned at the beginning of this chapter and at the end of chapter 2. Okay, that will now be replaced with this very easy power rule. Okay, and this is how we're going to apply it. So if y equals x to the 7, dy over dx is pretty much 7 times x to the 7 minus 1. Okay, so that exponent of 7 comes to the front, and we subtract 1 from it, just like the power rule says. So the derivative of x to the 7 is just 7x to the 6. Okay, you can even check that with the limit process. If you apply that limit process that we've been doing, that we've been using in this class prior to this video, then you will see that the derivative will be 7x to the 6. The derivative here, we just bring that 2/3 to the front. We subtract 1 from it, well, we know that we need common denominators. So 3 over 3 is the same as 1, and it allows us to write 1 as a fraction with common denominators, or with the common denominator of 3. So 2/3 times x to the negative 1/3. This works as your answer, or 2 over 3x to the positive 1/3. That works as an answer, or 2 over 3 times the cube root of x. All of these answers work. Okay, so the beauty of these rules is now we can go ahead and solve a problem like this, something that would take you quite some time using the limit process. Okay, we can do it in a fraction of the time by just applying these rules. So tangent point. So if it says find the equation of the tangent line to the graph of y equals x cubed at x equals 2. Well, if x equals 2, that means y is equal to 2 cubed. So we get 8. The point that we're talking about is 2 comma 8. Okay, now the slope is just the derivative. So dy over dx is equal to 3 times x to the 3 minus 1, which is just 3x squared. Okay, but if we want the slope at x equals 2, that means we get 3 times 2 squared, which is 12. Okay, so this is the derivative function, 3x squared. Once we plug in x equals 2 for x, we get the actual slope of 12. Okay, so using the 12, using the 2, and using the 8, we can plug that in to our point slope. Y minus y1 is equal to m times x minus x1. So we get y minus 8 is equal to 12 times x minus 2. Remember, this answer is fine. You can leave your answer like this and avoid risking doing some kind of simple math mistake, because if you try to rewrite this in slope-intercept form, and if you mess up somehow, that will cause you to get it wrong, because now you went from a correct answer to the wrong answer. Okay, but if you do want to put it in slope-intercept form, that's the answer. Okay. Okay, the constant multiple rule. If c is a constant and y is equal to c times f of x, dy over dx is equal to c times f prime of x. What that's saying is, if a differentiable function is multiplied by a constant, then its derivative is multiplied by the same constant. So get an example. So to find the derivative of y equals 5 times x to the 7, we just get dy over dx is equal to 5 times the derivative of x to the 7. So I'm just, remember that prime means derivative, okay? So x to the 7 prime means the derivative. So I'm taking the time to show this extra step to show you how that last rule applies here. It's just pretty much the constant 5 times whatever the derivative of x to the 7 is. finding the derivative of x to the 7 is not so hard anymore now that we know the power rule. So our final answer is just 5 times this derivative, so it's 5 times 7. Whoops, 35, not 37. X. And I made another mistake. That should be subtract 1. The power rule says subtract 1, not subtract 6. But the exponent should now be a 6. Okay? Same thing here, f of x equals 3 times x to the 5th power, so that's f prime of x is so pretty much f prime of x is 3 times whatever the derivative of x to the 5th is. Again, not that hard of a concept anymore, or not that hard of a problem anymore, now that we know the power rule. So that's just 15x to the 4. Okay? Then we have the sum and difference rule. So the derivative of f of x plus g of x. So in this case, notice that we have two different functions, the f function and the g function. Well, if we're adding them together, then the derivative of the sum is just the derivative of f plus the derivative of g. Same thing if we're subtracting, the derivative of f of x minus g of x is just f prime of x minus g prime of x. So let's go ahead and look at this problem here. It says combine the power rule, constant multiple rule, and the constant rule to differentiate f of x equals 4x to the 7 minus 3x squared plus x minus 4. So what we're going to do here is that last sum and difference rule tells us that we can go ahead and apply the derivative of each of these individually. So f prime of x is 4 times x to the 7 prime minus 3 times x squared prime plus x prime minus 4 prime. These are supposed to be brackets here. So that's a bracket. Okay. So this is just 4 times 7x to the 6 minus 3 times 2x plus the derivative of x. Think about that. What's the derivative of x? That's x to the 1. That's going to be 1. And the very first rule tells us that the derivative of a constant is 0. So we get f prime of x is 28 x to the 6 minus 6x plus 1. That's the answer. Okay, that is it for this video.